Yes, guys. Sorry for starting late because there are some urgent meeting called by HOD. Okay, so today we will start your subject, that is this for model one, measurement errors. Okay, first of all, we are going to see here what are the syllabus in your course and what how to follow it. Now see, there are total, wait, yes, there are total five modules. Okay, the whole subject is divided into five modules. First is measuring error. Second is transducer and measurement for current and voltages, principle of analog and digital instrument. Fourth one is oscilloscope and waveform generator. Fifth one is recording device and wave analyzer. In all these four modules you have to understand how to use that devices in your practical applications. Okay, so the subject itself name is principle of measurement and the instrumentation. So we have to understand what instrument means, which instrument is work on which principles, so you have to know well. So there are is less means there are less chance to lose the accuracy in your existing systems. So we will cover this all unit by using these two books. So one of the best book is AK Sauni, right? So first book is AK Sauni, second one is this electrical measurement and measuring instrument by this EW and this Vedis. So you can use with the help with these two textbooks, and there are also two reference book are given. Okay, so from that I will put on your classroom this AK Sauni uh, PDF and this one reference book PDF, this Kalsi. Okay, electronic measurement by this Kalsi. Okay, so these two books are I am put it on your this classroom link. But the edition is old. If you get new edition, please send me. I will put on that new edition on this your classroom. Okay, AK Sauni I will put there. I think a 1995 or 85 edition. So it is quite too old. So if you have new edition, then please send me. I will put it over there. Okay, so today I'm going to start this unit number one, that is measurement errors. Okay, in this module we are going to study this accuracy and the precisions and types of error, statistical analysis, and the probability of error and limiting errors. So there are some standard of errors we are going to see one by one. Okay, so different types of errors are there with different types of instrument. So we will going to see there. Now, first of all, my name is Om Prakash Kushwaha. Okay, so I am teaching first time this subject. I will try my best. Okay. Now, first of all, see here. What do you mean by error? Error what do you mean by error? Error is nothing but the difference of magnitude between the measured value and the true value is called a error. Simple. Whatever you want to measure some quantity, for example in voltmeter you are going to measure voltage, right? If you know the basic value of current flowing, for example in a resistor there are 5 ohm of resistor are there, for example 5 ohm are resistor, and you know the quantity of current which is 2 ampere flowing from that. By the Ohm's law, what is the voltage drop here, which is nothing but here V is equal to IR, right? 2 into 5, that is 10 volt. 10 volt is a true value. Okay, if you measure this quantity, so you will get somehow near about 10 voltage. Okay, or some of the instrument which give 9.999 volt. Okay, so there are 0.001 volt error in that measuring instrument. So it means error is nothing but the difference of your magnitude which is you measured and what actual the true value associate with that, that is called as a your error. Okay, so generally this error is classified as by this definition. Okay, so which you can also write is this error in terms of absolute error. Somehow some books it is also called as a absolute error. Absolute error. Okay, so absolute error is nothing but your E is equal to AM measure minus true value. Okay, now the error is also classified into two types. Now this is a error. So there are two types of error. One is uh, static error. Okay, one is static error and another is dynamic error. This is your static error and second one is dynamic error. Dynamic error. So static error in which the error is independent on time is called as a static error. Means the error which is not variate or which is not vary with respect to time. Okay, so it is independent on time, on time, and this is dependent on time, or you can say the error changing by with respect to time, right? Error is changes with respect to time is called as a dynamic error. Now the static error. Now see, static error by the definition, static error is defined as the difference between the measured value and the true value of the quantity. You can say that here the same definition we can use, but depending on the types of error, somehow in some of the point we are directly error called as a static error, and if it vary with respect to time, then we will call this as dynamic error. Okay, so now here we are more focusing on the static error. Okay, so a static error symbol is del of A. So del of A is nothing but your measure value minus true value. Now measure value is a value which is measuring on the spot, right? And the true value what is actual by theoretically you will get. Okay. So so whatever the difference by these two, which is error introduced by the your instrument or by the atmospheric conditions. Okay. Now how to correct it? So there are some correction factor also there. So you can express this correction factor with the by these definitions, or you can say minus of error. If you getting some major quantity, right? Or I can say that, now see, first of all read the definition here. The value which are the value which we are adding or subtracting from the measured quantity, right? You can also add it or subtract it for getting true value. Okay, that will be uh, the true value will be getting by this correction factor by adding this value to the measure quantity. Okay, so in order to getting the true value is called as a correction factor. So it is denoted by this del C, which is nothing but your minus of error. Okay. Now see, whatever the data I'm written here, that all data will be taken by this AK Sauni book. Okay. Now this measure minus true value, and if you see here, this measure minus true value is nothing but your delay, but the correction factor is true value minus measure value, which is nothing but your minus of delay. So it is also called as a static correction for this. Now, okay, so this is nothing but your correction factor. Now if I talk about uh, uh, some more quantity here. So first of all, we all cover the respective terms. Okay, then we will see the some example on that. Now see here, relative static error. Relative static error is nothing but the ratio of absolute static error, which is delay, to the true value of the quantity of AT under the measurements. Okay, so this is nothing but your relative static error. So you can also say that the relative static error is nothing but your absolute static error ratio of this. Okay, by definitions you can directly written this. And this relative static errors is important because relative static errors determine the quality of the your instrument, right? By saying just this single term, you can say if your instrument is good or bad. Okay. in, uh, in the manner of their accuracy. Okay, so we always use highly accurate instrument, right? Now see, so replace this delay with measure minus true divided by true value. So this is the one formula for your relative static error. Okay, and it is denoted by this epsilon r. Now, okay, so this is about the relative static error. Now if I talk about the term, which is nothing but your basic characteristics of the instrument, right? So if I talk about the terms here, basic characteristics of your instrument means we all, if I decide some instrument for measuring some quantity in a particular device, so I am interesting to focus on uh, this topic. Okay, so depending on the on these terms, so we prefer the highest accuracy, right? First is accuracy, second is linearity, third is we also try to see the what is the precisions. Okay, fourth is sensitivity, fifth is what is the date time of that instrument, date time, date zone, resolution, resolutions. Okay, uh, limiting error, limiting error, error, and guaranteed accuracy error. So this is nothing but your guaranteed accuracy error. Okay, so this th- while selecting the instrument, we have aware all these terms, and we will going to see one by one for respective terms, which type of instrument will be selected for measuring the any quantity to give the accurate result. Okay, so if I talk about the first is, uh, now see, this two is very important, right? Most of the instrument is depending or uh, differ by these two um, quantity, or you can say types of error, which is specified error in your instrument, right? This is specified by your manufacturer. Okay, manufacturer already specify these types of error on the all the instruments, and these types of error is the error which is variable in nature. Okay, and most of the time uh, this error is not specified by the your manufacturer. Earlier days it will be specified, but nowadays the manufacturer only specifies this guaranteed accuracy error. Now this relative static error is depending on your this guaranteed accuracy error. You can easily find out by knowing one of, if you know this quantity, you can by easily find out this. Now so I want to start with this two quantity. So first of all, see here, now only 10 minutes are there, so I will complete today limiting error. Okay, and in tomorrow class we will cover all of these things. So first of all, or I will cover guaranteed accuracy error. Okay, tomorrow we will cover this limiting error. So see, this guaranteed accuracy error. So guaranteed accuracy errors, that is GAE, is nothing but your fixed types of error which is specified by your manufacturer. By definition, you can say that, or somehow it is also represent in percentage guaranteed accuracy error. So it is nothing but your when accuracy is mentioned, okay, in terms of error, is called as it is called as guaranteed accuracy error. Okay, guaranteed accuracy error. Now if I explain this uh, with this error expected with respect to full scale value. Okay, so guaranteed accuracy error is always respected with the full scale reading. Okay, this is nothing but your with respect expressed with respect to expressed with respect to full scale reading, full scale deflection, you can say that, deflection. Now if you express these terms in uh, with this full scale deflection, so you can say that this is nothing but your percentage guaranteed accuracy error. For example, if the meter range is given for voltmeter, example, for voltmeter, okay, voltmeter for uh, 0 to 10 volt. Okay, 0 to 10 volt, and the mentioned term is that guaranteed accuracy error is nothing but your, or you can say 0 to 100 volt for guaranteed accuracy error is nothing but your plus minus of 1%. Okay, 1%. What do you mean by that? Guaranteed accuracy error, this is nothing but your percentage GAE, okay, guaranteed accuracy error. So, by this definition, guaranteed accuracy error is nothing but with respect to your full scale value, right? The express with respect to your full scale deflection, and the percentage is given to you, which is nothing but your plus minus 1%. Now, so if you measure the quantity, and if you the value of that is nothing but your 100 volt, let's say the full scale value is 100 volt, and guaranteed accuracy error is always with respect to full scale value. Okay, so what is a full scale value here for this meter is 100 volt, so that's why 100 into what is the accuracy, guaranteed accuracy. Guarantee means this instrument has a guaranteed error, means उसमें error होगा ही. Okay, because already mentioned this that the guaranteed accuracy error means error which has guaranteed present on this instrument, which is nothing but by this 1%. So at 100 volt you have the 1% error, which is nothing but here plus minus 1 divided by 100. Okay, because of this percentage, when you solve it, you will get plus minus of 1 volt. Means when you want to measure the voltage for full scale as well, you will get plus minus 1 volt error. So by the voltmeter you will get, if true value is 100 volt, if this is true value, okay, if, okay, let's say, if true value is 100 volt, if true value, okay, true value is 100 volt, then measure value is either 99 volt or 101 volt. Okay, 101 volt. So this is your, this is your measure value. Okay, so this is your measure value, measure value. So, what do you mean by that? This guaranteed accuracy error, the the instrument which has guaranteed of this error, okay, and this guaranteed accuracy error is always represent or represent expressed with the full scale range. सो इसमें जैसे वोल्ट मीटर में फुल स्केल रेंज इज 100 वोल्ट. सो इफ द गारंटेड एक्यूरेसी error is plus minus 1%. Okay, so now see, if the value is given in terms of this percentage, so it is a percentage error, right? Now the basic difference is that, now see, deviation and depletion. What do you mean by deviation? If the a meter has a plus minus of 1%, right, and b meter has a plus minus of 99%. Now this term is represent the deviations, right? Deviations in percentage, right? And the meter, which is c meter, has 98% of your uh, accurate meter, you can say, and d is nothing but your 1% accuracy. So this is defined in terms of your depletion. Okay, so if I talk about which is meter is the highest accurate, now see, this is a deviation, this is this all value with respect to your accuracy, right? With respect to accuracy. Okay, now if I talk about which meter is the highest, means 100% accurate minus plus minus 1% means a meter has a 99% of accuracy. Okay, so a meter has the highest accurate meter. After a meter, which meter is highest accurate? C meter, right? So this is your first, this is a second, third one is uh, this is plus minus of 99%. So b and d meter are somehow same. Okay, so this is a basic difference. So if I express plus minus of 1% means your meter has a 99% of accuracy. If you measure 100 volt, you will get either 99 volt or 101 volt. So see, plus minus is defined here. So either you will get 99 volt or 101 volt. So I hope this is clear, guaranteed accuracy error. Now tomorrow I will covered all rest of the points from this, and day after tomorrow we will cover some examples. Okay, so unit 1 is not very lengthy. It is some basic terms related to these errors. If you have any doubt regarding this some points, then you can ask. Yes, guys. Okay, no points. So okay, guys, we will start the class from tomorrow, I think 10 a.m., right? So you can leave now. Thank you.